Hello, Mrs. Endicott here. I'm going to work out a couple examples for you, showing you how you can use right triangle trig to solve for missing sides. Now, in order for right triangle trig to work, you need to have an angle and one side given to you. Then you can go find either of the other two missing sides. So in this problem, wherever the angle is that they give to you, that's where I put my theta. So remember, when we start these problems, based on where your theta is, you're going to have three sides: the opposite, the adjacent, and the hypotenuse. So I would go ahead and label those on my triangle. Opposite of the theta is the side furthest away. Adjacent to the theta is the side next to, and then the hypotenuse is always the side across from your 90-degree angle, and it's your longest side. After that, when you have your three sides established, that's what you use to help you determine which one of your three trig functions you're going to apply. So we have sine, cosine, and tangent. The way to remember is so, ka, toa. So sine is always O over H for opposite over hypotenuse. Cosine is ka, that's adjacent over hypotenuse. And tangent is toa, opposite over adjacent. So looking at this problem, I have the adjacent side and I want to find the opposite side. So you pick the trig function that uses the O and the A together. That is tangent, O over A. So I write the trig equation, which the general trig equation looks like this. Tangent of your angle equals opposite over adjacent. And then you'll plug in what you know. In this case, our theta is 25 degrees. So I can write tangent of 25 degrees is going to equal O over A. Opposite in this case happens to be my unknown, so you can put a lowercase b. My adjacent is the 8. Now, the easiest way to solve these is to think of it as a proportion where you can then cross multiply. So if I were going to solve this, I would take 8 times tangent 25, and it gets written like this where the 8's in front. And keep in mind, your degrees is always inside of one of the trig functions. That's why I put parentheses to show you the angle is going inside the trig function. That would be equal to 1 times b, which in this case is just b. Now this I can just type into the calculator. So if I type in 8 times tan of 25, I get 3.73 rounded to the hundredths. And I would want to see if that answer seems reasonable. So if you look back at your triangle, 25 degrees is going to be the smallest angle in this triangle, so therefore the side opposite of it must be the smallest side. So 3.73 seems possible because it's smaller than 8. That's how you would work out finding a missing side. And again, I chose tangent for this one because I was given the opposite and adjacent sides. I was given adjacent and I wanted to find the opposite. We did not need to involve the hypotenuse, which therefore eliminated sine and cosine for me to use. When I'm looking at this next problem down here, I again would label my theta wherever the angle is that they give you. So that's 52 degrees. Across from that, or opposite of that, is my 12. That's the opposite side. Adjacent is going to be this lowercase b. Oh, sorry, nope, that's the hypotenuse. This is the adjacent side. Hypotenuse is across from your 90. So, in this scenario here, I'm going to want to use the side that involves the side I'm given and the side I want to find. So in this case, that's the opposite and the hypotenuse. So if you look at SOHCAHTOA, opposite and hypotenuse is sine. So on the second problem, I'm going to use sine to help me solve for my hypotenuse. So your sine equation looks like this. Sine of theta equals O over H, and plug in what we know. We know the theta is 52, so that's 52 degrees. We know the opposite side is 12, so I plug in 12. And then we know the hypotenuse, in this case, is the B. Or you can put X if you prefer. And again, to solve these, the easiest way is to put over 1 and then cross multiply, just like solving any other proportion. So if I cross multiply, I'm going to have B times sine of 52 degrees equals 1 times 12, which is 12. Now, in this case, I can't multiply like I did on the problem above because I don't know what B is. Instead, I need to think of getting B by itself. So to do that, we're going to divide both sides by sine of 52. And what that does is cancel out that sine from both sides. So if I divide both sides by sine of 52, now I have something that I can enter in on my calculator. And so to rewrite that for you, I would say that B is going to equal whatever 12 divided by sine of 52 degrees is. So in my calculator, I type that in. Keeping in mind you do need to put the 12 first, otherwise it does change your answer. I get 15.23. Let's go see if that is reasonable for our triangle. We were finding the hypotenuse, so it needed to be longer than the 12, so that seems reasonable to me. And again, how we decided to use sine on this problem was based on the fact that we were given the opposite side and we wanted to find the hypotenuse. The only trig function that uses O and H together is sine. So I plugged in what I knew and worked it out. And that's it.